Hi, colleagues and students. My name is Kim Fai Ho, Associate Professor in Toxicological School of Public Health and Primary Care, the Chinese University of Hong Kong. Today, I'm happy to share my works on personal exposure of PM2.5 in Hong Kong, especially focused on their chemical and toxicological characteristics. Short-term and long-term exposure to PM2.5 are proven to be associated with adverse health effects, and we all know that most previous air pollution and health studies used ambient PM2.5 in the assessment of the association between air pollution and health. However, such ambient measurement tends to reflect the urban background of PM2.5 rather than the actual personal exposure, which can be significantly affected by different individual activities and the time spent in various microenvironments, such as in vehicles, home, office, and restaurants. In the past 2 decades, there are several population-based personal exposure studies in the US and in Europe. A limited study have been performed in Asia, like Hong Kong. Moreover, the results of personal exposure of PM2.5 are controversial. Some studies show the significant association between the ambient and personal exposure of PM2.5, but some are not significant. Therefore, accurate assessment of human exposures is an important research area for environmental health. The assessment of their relative contribution to personal exposure can provide valuable information for epidemiologists and regulative agencies. Studies on personal exposure of PM2.5 in Asia are still very limited. Therefore, local measurements are necessary to determine PM2.5 exposure level in Hong Kong. In our studies, we mainly use real-time samplers or field-based samplers for our measurement. Real-time sampler can provide high-time resolution data, which can help us to observe short-term variability of exposure level in different microenvironments. For field-based sampler, PM2.5 samples were collected on field media, which can be used for different chemical and toxicological analysis. Here we show what types of analysis we have been performed in our study. We determined the organic and inorganic fractions of PM2.5 and focus on those toxic species like heavy metals and pH. Moreover, in vitro studies were performed by using different cell line models. Other than PM measurement, it is important to know the time activity patterns of each participant. During the 24 hours monitoring events, each subject were required to provide a time activity diary denoting their location and activities in every 15 minutes. This activity pattern provides additional information for modeling in the future. In the result, we can observe that in Hong Kong, most people spend 80% of the time in indoors and around 12% of the time in outdoor, and the rest of the time spent in transit, restaurants, or other microenvironments. Here we show the results of personal exposure of PM2.5 in Hong Kong. In general, high exposure level were found in winter than in summer for subjects living in different districts of Hong Kong. Then, subjects were categorized into 4 main groups based on their gender, age, residential area, and their occupations. We can see that high exposure level were found in housewives and non-office workers. When we perform the correlations between ambient and personal PM2.5 exposure, we can observe fair correlation across seasons. If we separate according to their occupations, stronger association was shown for the office worker and student compared to housewives and non-office workers. Seasonal and occupational variations of personal PM2.5 exposures and the chemical components were investigated. Significant seasonal variation were observed in personal exposure with higher levels in winter and lower in summer for PM2.5 mass and most water-soluble ions. No significant seasonal variation were found for OC and EC in personal PM2.5. For most of the PM2.5 components, significant lower exposure level were found for office worker and student than other groups of subjects. The mixed effect model were used to investigate the determinants of personal exposure to PM2.5 and the chemical component. We can see that for 1 hour extra time spent at home, average increase of 1.7 to 3.6% in personal exposure to secondary inorganic aerosol were observed. For 1 hour extra time spent in transit, average increase of 2.7 to 12.3% in components of personal exposure to EC, titanium, and iron were shown, respectively. We then employed the PMF receptor model to estimate the source contribution to personal PM2.5 exposure. Secondary inorganic ions regional pollution, and regular exhaust were the major contributors to personal PM2.5 in Hong Kong. We then applied A549 cell lines to investigate PM2.5 bioreactivity, which including cell variability, LDH, A-isoprostane, and interleukin-6 levels, to explore which organic component were more potent in causing the observed biological effects. We applied a multiple regression analysis to investigate association between the analyzed component with the bioreactivities. We observed a reduction in cell variability and increase in oxidative stress and inflammatory response due to organic carbon exposure. And then we would like to test whether exhaled nitric oxide levels, which is a marker of airway inflammation, would be positively correlated with PM2.5 induced oxidative stress and inflammation marker. We found significant positive correlation between personal PM2.5 exposure-induced interleukin-6 and A-isoprostane level with exhaled NO. Traffic-related air pollution is one of the primary sources of PM2.5 in urban areas, which vary widely in space and time, although people spend a small fraction of their time in transport microenvironments. Short-term exposure to traffic-related pollutants provokes adverse health effects. To better compare the commuter exposure to particle pollutant while traveling in different transport modes, the same start and end points were selected. Along the similar routes, significant high commuter exposure to PM2.5 component were found in MTR carbon. Moreover, diurnal variation was observed for commuter exposure to black carbon and PM2.5 component at morning and evening peak. The relationship for PM2.5 component with cell variability and reactive oxygen species production were investigated. Moderate association were shown for the transition metal, especially for nickel, zinc, iron, and titanium, with PM2.5 induced cell variabilities and cellular reactive oxygen species. In conclusion, in our studies, we can observe that fixed air quality data is not suitable to represent personal PM2.5 exposure in Hong Kong. It will depend on their job nature and time exposure in different microenvironments. Chemical and toxicological characteristics of personal PM2.5 has significant association with human health effects. And nowadays, we can observe a wide variety of sensor technology is emerging. It will be popular to determine personal exposure with smaller, cheaper, and more sensitive package in the coming future. Here are the papers related to personal exposure studies in Hong Kong. Thank you very much.